Second question, calculate the delta H, and let's move this up. Calculate the delta H value for this reaction. I'm hoping you recognise the chemicals here. C2H4 follows CnH2n, and that's an alkene. I'm hoping you recognise that. So here's our alkene with 2 carbons, so it's going to be ethene. Here's chlorine, and C2H4Cl2, or C, here we're going to have, we need 6 atoms around the 2 carbons, so we'll have Cl, Cl, H, 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 H. And the last reaction that we looked at was a substitution reaction. This is definitely not a substitution reaction. Nothing's being swapped. All we're doing is adding chlorine. We're taking 2 reactants and making 1 product. So this is actually called an addition reaction. And you will have seen that when you reacted bromine with an alkene. You get an addition reaction. And chlorine will behave in a very similar way to bromine, because if you have a look in the periodic table, chlorine is in the same group as bromine. Now, back to our reaction. What do we do first? Is a bond's being broken first, or a bond's being made first? Well, that's right. You have to have the breakup at the start, as we discussed, just like a romantic comedy film. So bonds broken. And just like before, I'm going to break all the bonds. So I'm going to break 1, 2, 3, 4 CH bonds. I'm going to break a CC double bond. And I'm going to break a Cl bond. So let's look at our values. CH is 413. A CC bond is 614. And a ClCl is 243. So on your calculator, work that out. That comes to 2509. It would be as well to have a calculator and work these out, because I'm notorious for making numerous mistakes on calculations. So that's the energy absorbed when the bonds are broken. Let's work out what the bonds are made. So bonds made. Well, let's look at what we're making. We're making 1, 2, 3, 4 CH bonds. We're making 1 CC bond, and we're making 1, 2 CCl bonds. Don't forget the CC bond. Very easily done. So plug your numbers in again. So we got 4 times, that's right, 413. We got 1 CC, so 348. And then we got 2 CCLs. 2 times 3, 4, 6. And if we just work that out, that comes to 2692. And hopefully remember what we used in the last video. So delta H equals the breakup minus the makeup. So 2509 minus 2692, and type that into your calculator, and you should get minus 183 kilojoules per mole. I'm going to write it to the minus 1. Oop. Just press something on here. Do I want to save the project? Cancel. Here we go, to the minus 1. And that's your final answer. They might say then, or the examiners might then say, is this an exo or an endothermic reaction? We'll have a look. It's a minus sign, so it's going to be an exothermic reaction. They then might say, draw an energy profile diagram for this reaction. Right, so underneath it we could have an energy profile diagram. very quickly drawn. We've got energy or enthalpy on this axis in kilojoules per mole. Our reactants were C2H4 and Cl2. And it was an exothermic reaction, so the energy there is below, except it wasn't C2H6, was it? It was C2H4Cl2. And we've got a bit of a hump in the middle there, and that's not bad at all. We've marked on our reactants, we've marked on our products. Is there anything we're missing? Well, probably we should call this progress down at the bottom, but there's something very important that we're missing, and that's the delta H value. So the delta H goes from here all the way down to level with that line at the bottom, and that's minus 183 kilojoules per mole. It's very difficult writing with this pen thing I'm using, so excuse the scruffiness. Right, final question. It might be a good idea to pause the video, have a go at the last question and see if you get it right. Right, so maybe you need a bit of help with the drawing out of the reactants. Here we go, there's nitrogen triple bonded, and we've got 3 hydrogen molecules. And they form 2 ammonias. So here we got NH3 like so. Maybe now is a good time to pause it and try the calculation. So, start off with the breakup. I don't know why break suddenly developed an E at the end of it. And we're going to break the nitrogen triple bond and 3 hydrogen bonds, 3 HH. Okay, so let's work out our numbers. That's 941 plus 3 times 436. And that comes to 2249. Our make, well, we've made 1, 2, 3, 4, 5, 6 NH bonds. So that's 6 times NH391, and that comes to 2346. And so delta H, break up always comes first, break minus make, so that's 2249 minus 2346, and type that into the calculator. That's minus 97 kilojoules per mole. And again, the examiner might say, well, is this exo or endothermic? Well, it's exothermic because it's negative. Why is it exothermic? Because the energy absorbed when the bonds were broken is less than the energy released when the bonds were made, so overall energy is released. And they might then say, draw yourself an energy profile diagram. So we've not got too much room here, so here's N2, 3H2, it goes down, so delta H equals minus 97, and the products were 2NH3, and we've left off labels, so let's label that enthalpy in kilojoules per mole, and this is progress. And the key thing to do now is to go away and practice an absolute ton of these calculations, because actually they're quite routine, they're quite straightforward, and they should be a good mark banker if they come up in the exam.